Hi, welcome to lesson 3 of week 2 of Julia programming for novice beginners, in which we have our second look at functions, and now we are looking at user-defined functions, and we just aim to teach you the basics. So that means that after this lesson you'll be able to explain how to use the reserved keywords function and end to create a Julia function. You specify what names are acceptable for a user-defined function and how to specify the argument list in a user-defined function. There's an optional keyword return that you'll be able to explain how to use, and it specifies the value that is returned by the user-defined function. And finally, you'll be able to explain how to write an inline function in Julia, and when you write an inline function in Julia, you omit all the keywords. That is to say, all the reserved keywords. So functions are, of course, as we said before, extremely important in Julia. They are the main way in which code is organized into short bits that can be understood by human beings. And they're also the main way in which Julia achieves its spectacular speed of computation, and another attribute is that they enable the very large computational projects that Julia has already succeeded in. But we don't go into Julia's strengths in this course. So here's the basic function syntax. You use the keyword function. You have open and close parentheses, and it's actually important that there's no space there. And then you put the body of the function, and then you end. So you've opened a code block, and now you close the code block with the end. So let's look at this particular example that we've seen before. If we have a string ABCD, we can have it back to front by starting at end and going in steps of -1 down to 1. So let's write that out. So if I have a function, and the function is called spin, and it has an input variable which I will call str, and then I can press enter, and now you see that Julia is waiting for further input. I've started something which hasn't been finished, and Julia is waiting for it to finish. So let's make a bit of space, and let's then say we want to create a variable called y and make it equal to str, but we're going to index str from end in steps of -1 down to 1. And I press enter, and Julia still knows that it hasn't come to an end. Then I say return. What do I want to return? I want to return the value of y. And now I can say end, and that's the end of the function. So we want to line it up so we can see that here's the function starts, here the function ends. And if I have defined spin, so the return keyword returns the value of the variable or variables after it. So that's the variables that occur. We say return, and then we put a list of variables there with commas between them. In this case, we only have 1, so we don't need any commas. And now let's create, say, greeting. Well, now we can spin an input as long as it is a string, and we can do that. Or we can say greeting equals hello, what's your name again? And we, I don't want to see the output, that's a bit rude. So I'm going to spin it around and ask for what greeting looks like back to front. So what spin does is actually available by a built-in function in Julia called reverse, and it is much faster. But what we can do with spin is we can extend it to make a second method, and now we will give an input not only the string, but also an integer k. And what this does is it takes a bit in the middle. And so from the elements of k, the elements of the string str, from 1 to k we call that init, and then from end minus k plus 1 we'll call it to end, we'll call that finish, and then from k plus 1 to end minus k we'll call it mid. So that's arithmetic again. I don't want to emphasize it too much, but what this does is it reserves the first k and the last k characters of the string. It leaves them untouched, and then the other ones in the middle, it swaps them around, and then it uses join to join them all together into one string. So if we spin the mid here, and the init and the finish are not spun. Okay, so I can go back to this. I have to use the backward arrow, and I now want to say there's a k. And I don't want to do any of these. I think I will have to take that out. It makes it easy. If I now press return, it will create a new thing. So now I want to, and I don't want to return y, I want to return join or whatever. So I have init, and that is equal to str from 1 to k, and I have finish, and that's equal to str from well, it's up to end. I want it right up to the end. But where do I start? If I start at end minus k, then I actually have k plus 1 characters in finish, so I must actually start at end minus k plus 1. And then there's the midsection, and why don't we put the equals all lining up? It makes it a little bit easier to find bugs. This is then from k plus 1, so that is where init ended, and before str started, so that's end minus k. And let's see what we did here. We said y is equal to join. Now remember that join must apply to an array of strings. So we have the string init, and we have a string mid, but we want to spin mid, and we want to put in finish. And you might object that we are trying to define the function spin, and we are using the function spin to define the function spin. I'll explain what is going on there in a minute, and then we have return y, and then we can end it. Now we have two methods. We have this method, and we have this method. And so now I can spin greeting, and if I spin greeting with k equals, say, 5, then the first 5 characters of hello must remain unchanged. Hello, what is your name again? And so must the last 5. And so we see this rather funny character string coming out. If we make this 0, then we get the whole thing back to front. and we can try and make it, say, bigger. That's almost all of it, maybe 12, 13, and with 13 it's exact. What happens if we take 18? It gets to be longer. You might ask yourself, why is it longer when we try 18? Well, this is the first 18, and this is the last 18 characters. So that is already 36. Actually, what happens is mid is actually empty in this case, because k plus 1 is 19, and end minus k is less than 90. So to go from 19 to something less than 19 is a range with no elements at all, and so mid is an empty string. So what this illustrates is that in Julia, a function name can be used to name many, I say functions, I should really say methods that do different things. They are, in that sense, generic, because a function can always be extended with one more method. And Julia determines which of the methods to use from the argument list in a given call. So here we have an argument list with 2 elements, and here when we say spin of mid, mid is just 1 element, and so it's not going to use this function, this method. It's going to use this method because this one uses only 1 variable in its input list, and this one uses 2. We should make sure that we know what function names are acceptable. So any string that is a variable name in Julia is also a valid function name. And the exceptions are the reserved keywords, the type names, and a few other special words in Julia, which is not important for us to know on this course. We discourage names for functions that include exclamation marks and underscores. Julian's style is to use them in special ways that aren't part of this course. There is also another possibility, which is you should keep in the back of your head, which is that you may use a valid function name which is actually a built-in function or something like that. And there may be a conflict between functions that are defined in different places but have the same name. Julia is very good at avoiding conflict like that, but it can occur. So on this course, that will not arise as a serious issue, but it's something to know about in future. Okay, so of course we would like to put these into a .jl file and to run them from there. So without further ado, let us get to Notepad. And we have the function spin, which can be a string. We can use any other name we want. We can use XXX if we like. And what this does is it returns XXX from end in steps of -1 to 1, and we can end that. I would like to make it like that. And we have the function spin, and we can make it y and k. And then we have init, and that's equal to y from 1 to k. And we have finish, and that is equal to, and let's make the equal sign line up, that is equal to y. It's up to end, and it's from end minus k plus 1. Maybe I want to put parentheses there just to make it absolutely clear that I subtract the k and I add the 1. And then that will give me k characters at the end. And finally we have mid, and that is equal to y from k plus 1 up to end minus k. And we want to return and I don't have to say an equals here, I can just say join and the array, and the array is init, comma, spin of mid, comma, finish. And I can say end. And that's fine. Let us save that. We want to save it as function examples.jl. Let's say function egs1. Right. And if I now say, let's leave Julia. So Control D ends our Julia session, and we start it up again. And now I say include and the name functions egs1.jl. So if I've got names of files and I'm using include, and I start the name of the file as a string, so I open a string and I'm going to close it, but I just have fun. Well, in the directory, all of the names that start with fun can come up, and I just hit tab and it completes, or else I type it out, and it says I've got the function spin, generic function with 2 methods. That's the last bit of output that it makes. But I can now say new string is equal to oh, what lovely, whatever you want to complete that with. And I don't want to see that, but I can say spin new string, and using tab, and it just does it backward to front. But I can also say 5, or say 3. Let's look at that. If it's too long, so that's 18. That may not be too long. It is a bit too long. Oh no, greeting has not been defined. So let's keep to new string. It's not been defined, by the way, because we started a new session to illustrate things. And it says it's an attempt to index it at index 1 to 18. Well, let's do what the length is of new string. And it's only 17 characters long, and so 18 is too far. We can try 17 and see what happens. And it just basically puts 2 of them one after the other. So what has happened is that the mid part, so where's our code? Here. This part mid, it's from 1 to 7, init is from 1 to 17, and that is from end 17 minus 17 is 0 plus 1 to 17. This is from 18 to 0, so this doesn't work at all. So mid is empty, and that's why we get it just to repeat itself. We can see what happens if we add a character. Say, it should be a string, and we just add a character there. What if new string is actually not a string? So what if we don't use a string, but we use a number? And then we get an error message. What if we use a character? We get an error message. So we don't try to spin a character, especially not a character with several things in there. We should also test spin by itself, but that it works fine. So everything works more or less as we want it to. Spin by itself on a character is also a problem. So, now debugging involves more than just fixing invalid code. So let's see what happens if we change the functions in some way or other. So let's take this +1 out, which may have tempted you. So we save that. And again, just to be sure, I'm actually going to leave Julia and start Julia up again. And that is to make sure that everything we do is completely fresh and there's no functions or names or anything lying around from earlier in our session. And I can include this function. Okay, so now I expect things to go wrong. So let's have a string that we know exactly what we're talking about. And we say x equals a, b, c, d, e. And we say spin x. And we leave the two ends unchanged and we spin the middle. So what we expect to see is that a and e are unchanged, and then B, C, D is spun. But what we see is that there's a D at both ends. So we see DCB, but we see DE. So that was the point that I made when I first looked at the functions, is that if you have end minus k, so here, in our call here, k is equal to 1, and it's A, B, C, D, E. So end is equal to 5. So that means we go from 5 minus k, which is 3. Sorry, what are we doing here? K is 1. So 5 minus, so this is from 4 to 5. And it should really be from 5 to 5, and that's why there should be a 1. So this can be difficult to spot. There's no question that this kind of debugging is actually harder than the other kind of debugging, because now we have eventually found out that the result is wrong. And all we know is that this function is giving us the wrong result. If we're very careful, we can see that there is the DCB of the mid, and that's DE. And so if we're very lucky and careful, we can say the problem must be here, and that's because finish is 1 character longer than it should be, and then we put in the +1, and then that fixes it. So I can see if it fixes it if I just include it again, and the answer is it does. So you don't have to leave Julia the way I did for the first time, just to make sure that everything was clear. If you go to your code and you change your code and save it, and then you include that code with that function, that file again, then it will recompile the code and you'll get something new. So here's the return keyword. It's actually, as we say, optional. So if there is no return keyword, it will still retain a value, and that will then be the very last one that was calculated. So I can go to this, and I can return, I can change that, and I can take out this entire line. And now the function, I can, well, let's clear Julia completely again, because who knows, maybe you suspect that the functions are around from before, but now all I'm doing is I'm asking, so I'm pressing FU, then I'm using up arrow, and that brings back that piece of code. Now it's only one method, and I can now spin a string, and let's spin 1, 2, 3, 4, 3, 2, 1. That is actually the same if it's spun, so 987. And then that's 78, so that spins it fine. So that illustrates that the return keyword is that, and you can modify yourself the other spin function. So this paves the way for a great abbreviation. We can omit all the keywords and just use round brackets and an equal sign, but then we are limited to a function which uses exactly one expression. So let us define spin in that way, and just to make sure that you realize that the actual name we use is not important, we have x, y, z, and we take it from end in steps of -1 to 1. So what has happened here is that the function spin is assigned this value. So when there is still a generic function with one method, and if we do that, we still get it back. But the code of spin is now, the function is now just a single line rather than these 3 lines, and these 3 lines rather than the 5 we had before, and so on. So we're making it more and more compact. And this is for convenience. It's very nice when you write code to be able to have your functions very short. You see, maybe you have 4 or 5 functions, you see them all, they're just one line, and then you have another function which combines all of the functions that you had before, and all of them are very short, very clear, and you can very well understand what your code is to make sure that it doesn't contain any mistakes. One last way to write functions, the third way, is anonymous functions where you don't even have to use a name. But this is mainly used for iteration, which we will address later on in the course. So we end lesson 3 of week 2 here. And as before, please make sure you do the exercises.